The second type of transformation we have is a non-rigid transformation. In geometry class, our non-rigid transformations were our dilations, our expansions and the contractions of our geometric shapes. For non-rigid transformations of functions, it basically does the same thing. It's going to cause a function to stretch or to compress. So if I have a function f of x, in order to get a non-rigid transformation, you are going to multiply that function by a number, and that is going to give you g of x. And that number is going to define what actually happens to the graph of the function. If a is greater than 1, it is going to cause a vertical stretch. And I'm actually going to put the absolute value of a, and we'll discuss that in a minute. And if the absolute value of a is less than 1, but greater than 0, we're going to call this a vertical compression. From the last video, you should remember that if a is negative, it's going to cause a reflection across the x-axis, and then it will have a stretch or a compression based off of the absolute value of a. So for a specific example, if f of x is equal to x squared, and I want to actually graph the function g of x, which is equal to 2x squared, so this f of x is my parent function, the 2 is going to cause a vertical stretch. So if we actually put numbers into my function, I'm going to graph both f of x and g of x. This is x. This is y. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So f of x, if I put a 0 in, I get 0. I put a 1 in, I get 1. I put a 2 in, I get 4. Graph using symmetry. This would be my function f of x. G of x, I take each of these values and then multiply them by 2. So 0 times 2 is 0. The 1 times 2 is 2. The 4 times 2 is 8. Graphing using symmetry. And that would be my function g of x. So when I discuss something as a vertical stretch, in layman's terms, I'm going to say that it shoots up faster. Or we can say it shoots up or down faster. If it has a vertical compression, the way to think about it is that the graph is flatter than the parent.